Next matrix is Toeplitz matrix. See, this is a Toeplitz matrix of order 5 into 5, 5 cross 5. Let us observe the matrix. This is having all non-zero elements. Then what is the property of this matrix? So if you observe, the elements in a diagonal are same. 2. All numbers are same. And the elements in lower diagonal are same. Okay, these are also same. These are same. Upper diagonal, again they are same. These are also same. So elements in a diagonal are same. So it means 5 comma 5 element is same as 4 comma 4. That is same as 3 comma 3. So from bottom I have started. Then if I take this element 5 comma 4, that is same as 4 comma 3. See, 5 minus 1 and 4 minus 1, 3. So it means that if a matrix is having elements such that M of ij is same as M of I minus 1 and j minus 1. So this element is same as this one, this is same as this one. So which is the original element? This is the original element, we can say. This is the original element for this one, this is the original element. So when the elements are repeating, there are duplicated and there is some pattern followed, that this is the pattern followed. Then we don't have to store all non-zero elements. Then how many elements are sufficient? It is sufficient to store a row of elements and a column of elements. This is sufficient. And this is a common element, so we have to store only first row and first column. Then how many elements are there? See, elements, if I take, first row is having n elements, that is n, that is 5. Then column, I don't have to take this again because this is common, so this is n minus 1 plus n minus 1 elements. So only these many elements are sufficient. So let us see how to represent this one. So I'll take an array and store all these elements. So what should be the size of an array? Size of an array should be 5 plus 5, 10, 10 minus 1, 9. So I will take an array of size 9. So I have taken an array of size 9. Now how to represent these elements? So I don't have to store all the elements. First I will be storing first row element. Then let us store column elements. That is sufficient. So first row elements 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6. This is row. And first column element 7, 8, 9, 10. So these are 7, 8, 9, 10. And this is column. So mapping of these elements I have done. Now what should be the formula for retrieving the elements? See, if the elements are in the upper triangular part, means these elements that are in a row here, and these lower triangular elements, they are in a column. So how do you identify the elements here? So here the indices are such that I is less than j, but including diagonal. So I is less than equal to j, it means the elements are of this upper triangle. So for any index of an element a of I, j, then the formula we can come up, case 1 is if I is less than or equal to j, means the elements in upper triangle. So for example, I want 3, 4 or 3, 5, 2, 3, 2, 4 or 2, 5, any of these elements. So 2 is smaller than 3, 4, 5 and all. So 2 is smaller than 3, 4, 5. So that's what I is less than equal to j means the elements are in upper triangular part of a matrix. So they belong to a row. So I should get an element from here. So I'll take some examples and show you. Suppose I want an element at a of 2, 4. So 2, 4. 2, 4 is 4, that is 3, and that 4 is present here at 2. So how I can get the index? So let us subtract 4 minus 2, that is 2. Then what about the element that is 3, 4, that is 3, and this one 3, 4. So 3, 4, the element 3 is at 1. So let us do 4 minus 3, it is 1. So it means if I subtract j minus I am getting the index. So for case 1, upper triangle, how we should retrieve an element? What should be the formula? See, these are all diagonal elements. So diagonal elements means I minus j is equals to 0. So yes, this element 2 is present at 0. Then these elements 3, 3, 3, this is I minus j. If I do, this is minus 1. And the element is 2 and it is at index. Element is 3 and it is at index 1. So yes, 1. So this I am getting minus 1. So let us make it as j minus I. So this is plus 1. Then these elements, that is 4. So if you take j minus I, this is 2. So 2. So the element is 4. So it is present at index 2 only. So this means I can obtain the index of any element in this array by doing j minus I. So yes, index is j minus I. That's it. Then second case, what about the elements that are in lower triangle? So case 2, if I is greater than j. So these elements. Then if I want this element 7. So if I do I minus j, this is 1. And here I minus j is a 2. I minus j is a 3. So this is 1 and 3. The elements of this diagonal are 1, that this diagonal is 2, this diagonal is 3. Now let us observe there where it is, starting from 5. So first of all I have to leave all the elements of this row, then I can go there. So index will be n plus. So leave 5 elements. Once we leave 5 elements, we'll be on 5 and this should be 0. Wherever you are now, that location treat it as 0. So if we are here, let us call it as 0. So that 0 means here we get the index as 1. So minus 1 we can do. So this is I minus j minus 1. So this is the index for lower triangular elements. So that's all about Toeplitz matrix. So we'll write a program and we will write a program for Toeplitz matrix. I'll be discussing the program.